All right, you guys, welcome. My name is Jason Massey. I'm with Sudhir here. We're going to talk about some vVOLS stuff. Who here is familiar with vVOLS? A little bit? Okay. So I'm going to give you a quick rundown on what vVOLS is, and then I'm going to let Sudhir talk about really what enables vVOLS to give you all of the array features for stuff like Oracle RAC or SQL or something like that. So really quickly, this is kind of an introduction here, but I want to jump through this so we can get into some information. If you're not familiar with vVOLS, what vVOLS are, the easiest way to understand what a vVOL is a well-orchestrated RDM. Now, RDMs are by far a four-letter word, right? We don't like RDMs. You have to manually provision them, you have to manually zone them, you have to manually manage them. They're a nightmare. vVOLS works physically similar to an RDM in that a single object, a single VMDK, can be dedicated to an individual VM, but all of that manual process that you have with RDMs goes away with vVOLS. It's all managed in vSphere. But one of the big benefits with vVOLS is that you get all of the arrays features, not a subset like you might with VMFS or NFS. Now this kind of gives a little bit of a layout on kind of the overall architecture of how vVOLS work. When a storage administrator sets up vVOLS, you provision or allocate what we call a storage container. The storage container is a logical allocation of space. So when you actually provision vVOLS, you're not physically creating anything. You're just saying, I'm going to let vSphere use this amount of space. And because that's a quota, it can be increased or decreased, unlike traditional LUNs or volumes, where once it's created, you can't decrease that size. You can increase them, but you can't decrease. But with vVOLS, that storage allocation, because it's a quota, as long as you don't reduce it below what you're actually using, so let's say you provision 30 terabytes and you meant to provision 3, you can just change that, hit a refresh on the data store, you don't have to do a storage rescan, and it will show the new value. Now, once you have that provisioned, you do something called registering a VASA provider. The VASA is something that VMware and our storage partners write together that allows you to use all of the array features. Once the VASA is registered with vSphere, then you can create the vVOLS data store. A vVOLS data store looks just like a regular data store, operates just like a regular data store. You can script against it just like it was a regular data store. It's really the back end that's different. Now, here's where vVOLS is different. Before, with VMFS or NFS, if you want a specific storage capability, you provision that to that entire data store. And that data store now has that fixed storage capability. Whatever that might be, deduping compression, replication, any of those. It's fixed. You can't change it. And it's for everything that's in that data store. With vVOLS, that's not the case. You now allocate the storage capability using policies. So you can have one VM that has a certain type of capability, and in the same data store, a VM that has completely different storage capability. This is all based on your provisioning of these storage policies, and it does not have to be fixed. So let's say you provision a VM and it's got, let's say, this test and dev, and you want to change it to production. You do not have to do a storage vMotion to a different data store. All you have to do is change the policy. So now you're managing storage capabilities at a VM level using policies. And you get all of the benefits of RDMs, minus all of the provisioning and manual management. You no longer have to keep track of all these objects. All these objects are managed and created automatically by vSphere. And now you get to manage all the storage capabilities, and it's very dynamic. You actually even can set individual disk capabilities. So if you had a VM, like we're going to talk about with multiple disks, and you want one disk to have one storage capability and a different disk to have a different storage capability, normally you would have to split those across multiple data stores. Now all you have to do is apply different policies to different VMDKs. they still can all be in the same data store. So with vVOLS, the way that vVOLS works with the storage features is all of the array features get presented up to the VM level. So whereas with VMFS, because we have VMFS or even NFS, that's a shared system that limits some of the capabilities but allows the hosts to all talk to and do locking. The vVol data store is not really a shared, it's a shared access. But the VMDKs, the actual VMDKs themselves, which are now a vVol object, are directly provisioned to a single VM or a subset of like a VM application. Okay? So the other big advancement that we did, which we announced this in vSphere 8, is we now also support NVMe over Fabrics with vVols. Now this is a perfect marriage of two awesome technologies, because with NVMe over Fabrics and NVMe, right? Each storage allocation is a namespace, which you can kind of think of that as a LUN or a volume. Well, now the way we've got this set up is that each vVol object is now its own namespace. And before, where I didn't really talk about the protocol endpoints, this goes into more technical detail. And I have all of this on core.vmware.com if you want to learn about this stuff. The protocol endpoint, which is kind of a proxy to the sub-objects, the vVol objects themselves, is now virtual, and none of this, all this architecture is automatically set up when you register with NVMe over Fabrics. So before you had to do a little bit of a manual configuration with the PE. With NVMe over Fabrics, it's all automatic. It's also very dynamic, and the reason I have this graphic here is multiple NVMe subsystems. So if your array controller supports multiple subsystems and even potentially the capability of across multiple arrays, vVols now has that built in to be able to migrate some of these namespaces or these vVol objects to different NVMe subsystems. Another big benefit that we did too with NVMe over Fabrics is we have in-band migration when you're doing vMotions between different objects. So before, if you do migrations or vMotions and stuff like that, in some cases, it goes through the VASA provider that I showed you before. Now with NVMe over Fabrics, it doesn't go through this out-of-band management, it actually goes through the in-band NVMe protocol. Some additional benefits there. So that was kind of a quick rundown on vVols. I can talk about vVols for like 2 hours, no problem. Is there any quick questions on what I've presented? No. Okay, I'm gonna hand it over to Sudhir now.
All right, I'm gonna talk about some things blazingly very fast, right? But before I start, here's the thing. So Jason spoke to you guys about vVol, right? Very high level. Let me ask you this. Are there still RDM believers in the room here? Just let me know. That's okay. There's no shame in saying that, because I will transform those RDM believers into vVol believers, and here's how, right? But even before we do that, when you see this word Oracle here, just take it out and put SQL Server, right? Because the use cases are exactly the same. Take SQL Server out, put SAP, works like a charm. See, what happens is, when you start looking at these databases, right, aka Oracle, SQL Server, so on and so forth, there are multiple challenges we have. Everybody focuses on day one. They say, oh, you know what? Provisioning, installation, configuration. Trust me, that's easy. That's the easy part. The day two part, where you have to start doing backup, restores, recovery, cloning, patching, creating new instances. And I've been a database administrator for like 26 years before I joined VMware in 2012. So I come from the Oracle DBA, the database group of families, right? What happens is the day two operation basically takes a big chunk of work from any DBA's life, right? The fact that your databases are growing from leaps and bounds, you have that backup window. Let me give you an example, right? You have a company that works from 9 to 6 in the morning, and then 6 o'clock in the evening, the data warehousing job starts, goes all the way till 2 o'clock. You have a backup window from 2 to 5. 6 o'clock, people comes, the operator comes, and the work starts, right? You have 3 hours. You cannot say, I'm so sorry, my backup is going to spill over more than 3 hours, because guess what happens, right? Your shop floor will not open, and you or me probably will have to search for a new job. That's the whole thing about being a DBA, right? The fact that when database grows up, time taken to back it up, that grows, or time taken to, let's say, clone it or refresh it. Everybody talks about storage-based replication, but Jason just pointed the fact out, right? If we have to do that, every VMDK is a LUN. Guess what happens at some point of time? You start running out of SCSI LUN limit, right? Every time you have a data store that takes a SCSI position, even though we increase it to 1024, it's the same thing with RDM as well. You now have to go and provision another vSphere cluster because you ran out of SCSI IDs here. Right? Now let's look at a simple use case, right? Backup and restore. The finest level of granularity that you can get in any of these day-to operation is always on the application level, right? Not the VMware level, not the storage level, the application level, which means if I have to, let's say, back up a database, a table space, or a data file, right? We don't have to go into the internal constructs of a database. That's the fastest way of doing it, right? Or that's the finest level of granularity. But you want to be on a virtual machine level because essentially your VM comprises everything. The database, the redo log files, the backup, the archive log files, the operating system, because you need the consistency group. But remember, with VMware Snapshot, yes, if you take snapshot of snapshot of snapshot, and you guys are VMware experts, you know what happens, right? It takes a long time when you start to delete it or coalesce it. Third, storage level, that's the fastest. But that's the problem. You don't have the granularity. So what you want is the speed or the granularity of the application with the speed of the storage. And that's what vVOLS are. Right, at the end of the day. Many moons ago, right, when people started talking about RDMs and VMDKs, they came back probably 12 years ago. Oh, you know what? RDMs are much superior than VMDKs. Well, with VMDKs, with so many VMDKs on an RDM or on a LUN, you have that noisy neighbor effect and so on and so forth. Performance was an issue. What happened was VMware engineering, they tested VMDK versus RDMs, and this was what, 3.5? Or probably 3.0 or 5. You know, I just put it here for legacy's sake. I just want to drive a point home that we already proved that the performance difference between a VMDK and RDM is marginally close to 1%, right? So if we move that biggest elephant in the room, I'm not talking about me, the performance elephant of the room out, right? Let's look at operational use cases here. Another guy could stand up and say, well, you know what, with RDM, we were able to eliminate all these noisy neighbors. I get it. With VMDKs, you do have that noisy neighbor effect, but you're able to do the same thing with vVol. So you don't really need RDM. See, I'm trying to sell vVol to you guys. I think I'm doing a good job here, right? Granularity of operations, you don't need RDM. With VMDKs, yes, you don't have the granularity, but you do get the granularity with vVol because at the end of the day, you can have your cake and eat it too because what's a vVol? It's a VMDK. It's a cross between a VMDK and RDM at the end of the day. That's what a vVol is, right? Number of devices, and we spoke about it. RDM maximum 1024. vVOLS 4000. So if you're worried about operational efficiencies, you're worried about scaling up and scaling out, you're worried about performance, there in a nutshell, you have vVol. That's the answer for you, right? And from a use case perspective, people could stand up and argue and say, you know what, I have an Oracle rack, it's sitting on a physical server. Well, I need to move it to a virtual server, the VMware environment, and that's the reason why I use RDMs. I get it. You could use RDMs for transition. But once you transition that over, you can storage vMotion it to a vVol. And there are use cases where with 8.0, we are able to show how you can hot extend. You can hot extend an Oracle rack cluster device without any downtime. I'm going to come to that as well. Unless you guys or anybody here says, I use NPIV, and we see very few customers using NPIV, you really don't need RDMs, right? So let me just stress, you don't need RDM, guys. You need vVOLS. Noisy neighbor. So look at the virtual machine on the left-hand side, right? And I was just talking to a couple of customers. In fact, I spoke to Jason. I'll give you an example here, right? Everybody knows what SIOC is. Everybody knows what NIOC is. I'm not going to talk to you guys about that. We know what shares are. We know what reservations are. We know what limits are, right? And we know exactly how to set SIOC. But there's a problem here in this slide. There's an issue in this slide here. What's the issue? It works when you have two different virtual machines, correct? On the same resource pool. If you have a VM, and if I give you two VMDKs, and you have a DB1 on one VMDK, a DB2 on another VMDK, how would you resolve the noisy neighbor effect? Anyone? You cannot. You got to use operating system device or the methods or mechanisms, or maybe on the Oracle side, use resource manager. You see the level of throttles that you guys have to set it up? DB level resource manager, OS level resource manager, SIOC, NIOC, shares, limit, and reservation. Move. Right? Seriously, you want to go through all of that? How about if you were to move it to vVol, You eliminate that noisy neighbor effect because think of it, Jason pointed it out. At the end of the day, a vVOL is nothing but a physical device crying out loud, right? It has that VMDK layer on top of that. Underneath, it's a vVOL. And you're not talking to the VMFS clustered file system. You're talking to the array directly. So performance, operation efficiency, noisy neighbor, cloning, patching, refreshing, and I can go on. And we actually wrote a paper on that as well, right? vVOL is the answer to any of your application workload. Doesn't have to be Oracle at the end of the day. Let's look at DB Restore here. Databases, Oracle databases, they are not 500 gigabytes or a terabyte, right? Typical Oracle DBS production database is 10 terabyte, 20 terabyte. If I have you to restore a 10 to 20 terabyte Oracle database, what are your options here? Oracle RMAN, man, that's going to take a long time, right? It's going to churn and churn and churn. You basically have to tell the DBS, come back tomorrow. Take a break. Come back tomorrow. You'll have your database, right? That's one way to do it. Second, back to his point. What if we use RDM for Oracle databases and we do the snapshot or the snap restore? Very fast. But hey, I'm introducing another problem here. SCSI run limit. With vVOLS, if your VMDKs, aka Oracle databases, are on those vVOLS, all you have to do is go back and use any plugin. I just use the pure plugin here. For example, you could either do a storage-based restore or a VMware plugin for that particular storage vendor based restore. All you just say is override it. So let's say, for example, you're doing some testing on a database, correct? So you took a snapshot, right? And then say something horribly happened and you have to restore it back. You would shut the database down. You would go, open up the plugin and say override the current VMDKs from a snapshot that I took an hour ago, and lo presto, the snapshot is restored. You will start the Oracle database up. In this case, since the DB was up while you were doing your testing, you may have to do crash recovery, which is what Oracle does instantaneously. You guys don't have to do anything for that. If the database was shut down cold, it does a cold restore. So all I'm trying to show you here is the speed of those restores, right? Trust me, when we had to go back to days when I used LTO3 tape, and those restores ran 3 days, I basically had to go back to my CI and say, you know what, take a vacation, come back after 3 days, I'll have your DB ready, right? So I come from that legacy era of tapes where vVOL essentially solves most of these issues here. Rack. If I have to restore an Oracle rack, remember, you cannot take a snapshot of an Oracle rack using multi-writer VMDK because of KB article 1034165 or 2121181 of vSAN, because it's disallowed. I just took a storage-based snapshot. So I shut the Oracle rack down. If I want to, I take a storage-based snapshot. I bring it back up. The Oracle DBAs do their patching. Something has horribly gone wrong. Shut the Oracle rack down. Restore. From that vVOL snapshot, it takes instant. It's seconds. Once the restore happens, start the cluster backup. You're up. Your RTO, your RPO, everything, you're able to meet the business SLAs. This helps you meet business SLAs. It helps you overcome those operational efficiency or inefficiencies, and you don't have to live with RDMs. So essentially, it's like a Swiss knife, a Swiss Army knife. Coming to the real thing here, right? Hot extending online Oracle rack disk. And I've already spoken about the fact that if you have an Oracle rack cluster, 2 node, 3 node, 4 node, whatever, right? And if you use VMDKs, you use multi-writer flag, there are certain restrictions currently as of now. You can't do snapshots, you cannot do clones, you cannot hot extend it, right? Yes, you can do vMotion, but you can't do storage vMotion. Let's say you have that setup in your shop, correct? And if you have to hot extend that Oracle rack devices, those cluster devices, you have 2 options here, or probably 3 options here. Shut the cluster down, which you cannot, you lose your job. So shut the cluster down, take all those multi-writer entanglements out, increase the size of the VMDK, put everything back in, but it's like taking the arms out and putting the arms back in, right? Trust me, it's very messy. Option 1. Option 2, I can then add another, let's say I'm moving from a 500 gigabyte to a terabyte, I'd add another VMDK of a terabyte clustered. I use Oracle ASM mirroring, and I move all the extents from the old to the new. Another way of doing it. Third, all I do is I just use vVOL, right? So the setup here is on 8.2. What we did was we had an Oracle 19.19, which is the latest and the greatest from the Oracle 19c family, running on OEL 8.8. I had 2 Oracle rack virtual machines. It had 3 VMDKs, and just go with the example here. I did not use best practices because I wanted to get something out real quick and dirty here. So what I did was, on hard disk 1, that was the operating system. Hard disk 2, I had the Oracle binaries, the ASM binaries. The hard disk 3, in fact, I used NVMe controllers. I use virtual NVMe controllers on the guest operating system. It was from an NVMe storage, right? And that was using multi-writer VMDK, right? Once I set it up, I have to hot extend this Oracle clustered, right, multi-writer devices without shutting the Oracle rack down. And this is how I did it. I basically I want to move from, let's say, 500 gigabyte to 600 gigabyte. All I did was on rack virtual machine 1, so you have to pick one VM. Pick rack VM1, increase the VMDK size. When you increase the VMDK size on the vSphere level, the size starts increasing on the storage level, right? So once the storage extension is done, basically the storage GUI. What about the storage GUI you guys are using for vVol? It'll come back and say, done. I have increased it from 500 gigs to 600 gigs. So that's step 1. Step 2, you can see both on the virtual machine side that your new size is 600 gigabyte, but the ball doesn't stop here, right? I got to go onto the operating system, right? When I go to the operating system, I rescan the bus. What do I see? The size is still 500 gigabytes. I haven't increased it to 600 because the partition table still sees 500 gigabytes, right? So what I need to do is on rack 1, on any one virtual machine, I delete, I recreate the partition table. And no, you don't have to shut the Oracle rack cluster down. You don't have to shut anything down, right? When you delete and recreate the partition table, right? The partition sees 600 gigabyte, but I'm not done here because the OS sees 600. Oracle doesn't see. Now Oracle needs to see 600. What you do at this point of time is the cluster services are still running. Log on to ASM. Just run this command. This is a non-intrusive, non-obstructive, non-obtrusive. It doesn't take anything down. It basically says resize the device to the maximum. So it increases from 500 to 600. So you got to do it at 3 different levels or 4 different levels, right? The VMware level, make sure on the storage level, yes, it's increased. VMware will report that. On the operating system, you go scan the bus. You see the old size, increase it to the new size by recreating the partition. Once you're done, on the ASM size, just run the command. If you don't want to do this, sure, you want to go back to old school, sure. Humor me, go back, add another ASM device, do all these extent creations and mirroring and so on and so forth. After a couple of hours, come have a talk to me. I'll have a cup of coffee. Or you want to do this, it takes a couple of seconds. So again, you guys decide, which way do I want to go? The easy way of doing it or go back to old school, right? Definitely you don't want to go back to old school. But anyways, for the non-believers in the audience, people who don't believe anything, people who are paranoid like me, I come from old school, right? That's the YouTube video. So I recorded a video and I say, hey, you know what? OE of little faith, if you guys want to see something, go back and look at the video because that shows you step by step how you can do that. But I think I have like 4.5 minutes or something. We finished a bit early here, so we'll be more than happy to take your questions. But if there's anything you want to take away from this discussion, anything, it's that one link here. Because everything that we produce, Oracle on vVOL, Oracle on vSAN, Oracle with workload performance, tuning, characterization, anything, it all gets dumped here on this blog site. We maintain it, and that's the virtual volume paper as well. And this is the paper that I co-wrote with Jason here. That goes into all of the use cases that I unfortunately couldn't talk about in this session here today because I had 25 minutes. But if I had, like, say, 2 hours, I would talk about patching, restores, backup. I would talk about rack, hot extend, and so on and so forth. How vVOL basically saves grace at the end of the day. So I'm assuming at the end of the talk there are no more RDM lovers. But if there are any more RDM lovers, please do come talk to us. And the thing is, we will transform you guys from RDM to vVOLS. You have anything to add to that? No. Right? Yes, sir. We're done. I think we are getting kicked out of the stage. So right after this, let's talk about it. But anyways, thank you. Thanks for coming.